So we've talked about rates and unit rates before, and here we're going to look more specifically at the rate of change as it is connected, and rates as they're connected to linear relations. And so the rate of change is the ratio of the change in the y dependent variable to the x independent variable. So the rate of change is the change in y over the change in x. On the graph, we call it the rise over the run. And so here we have a couple graphs. This one is an increasing graph. So if we take any 2 points on the graph, we can count the rise and then count the run. And it would be the rise over the run would be our rate of change. Notice I got a plus sign here. In this case, I got a minus sign. We always count the run from left to right because we read our graphs from left to right. So an increasing graph, the rise needs to be positive, and a decreasing graph, the rise would be negative. And you'll see that when we do some of our work. When the graph is increasing, going up to the right, the rise will be positive. When the graph is decreasing, going down to the right, the rise will be negative. The run is always positive. So that's just a restatement of what I just said. You'll also hear this concept termed as slope. So the rate of change for the linear graph, we call that the slope of the graph. If you think of, you hit the slopes and go skiing. This is the hill. This is the steepness of the hill, the slope of the hill. That is where that term kind of fits. So we're going to use some graphs to create some tables and determine the rates of change. So here we have a distance time graph in seconds and centimeters. And we want to look at these different intervals. Look at the rise, look at the run. So from 0 to 1 second. From 0 seconds to 1 second, the rise is going down, so it's going to be negative. And it's going down from 40 to 30. So the rise is negative 30. The run is 1. It's going over by 1 second. So the rate of change is the rise over the run. Negative 30 over 1, which is just negative 30. From 1 to 2 seconds, we go from 30 down to 20. So that is, I made a mistake there. Let's fix that first one. We didn't go down by 30. We went down by 10. We went down by 10. So those of you that were going, what's he talking about going down by 30? We went down by 10 in that case. We went down by 10. In this case, we also go down by 10 from 1 to 2 seconds. And from 1 to 2 seconds, we go over a run of 1. So again, it's negative 10 over 1, which is just going to be negative 10. From 2 to 4 seconds, we go down by 20 in this case. Negative 20. And we run over 1, 2. So that's going to be negative 20 over 2. But again, that simplifies down to negative 10. Negative 20 divided by 2 is going to be negative 10. And we can illustrate these with a little triangle, our rate triangles. So we're going down by negative 10 over by 1. Here we went down by negative 20 over by 2. So you see that with the linear relation here, we have a constant rate of change. And that will always be the case with linear relationships. The rate of change will always be the same. The slope will always be the same. Now in the case of our next graph, distance and time, it's a curved line. So things are changing a little bit here. If we go from 0 to 1 seconds, and we have this rate triangle right here. We're going over 1, so it runs 1, but our rise is 10. That's about a little under half, so maybe 24. So that's 6, so maybe down 16. So our rise is negative 16. Our run is 1. Thus, our rate of change is negative 16 over 1, which is going to give us negative 16. In the next case, going from 1 to 2 seconds, So we're going from about at 24 here, we're going down to about 12, let's say. So from 24 to 12, sorry, 24 minus 12, we're going down by a total of 12. So negative 12 is going to be our run here. And I'm going to write that differently. I'm going to take the second value, the 12, and subtract 24. So then we get negative 12 as our answer, which is what we need. We need to be decreasing. We take the second value, subtract the first value. That was my mistake in there in showing that. And that gives us a run of 1. So our rate of change, though, is going to be negative 12. In the last bit, going from 2 to 4, we're going down from 12 to 0. So we're going down about negative 12 again. But our run is 2. So negative 12 over 2 is going to give us negative 6. So negative 16, negative 12, negative 6. We have a variable rate of changes. Not the same. It seems to be decreasing in speed there, going down. So if we want to compare our rates of change, the linear relation is constant, and the nonlinear relation is variable, meaning it's changing. So that's always going to be the case. Linear relations will always have a constant rate of change. Nonlinear relations, anything with a curve, is going to have a variable rate of change. So here we have a table set up, and we want to calculate the rate of change for each interval. So I'm just going to add an extra column here. Rate of change. So there is no interval here, but there is an interval here. So we're going from 500 to 0, negative 500 to 0. So our rise is 500 over the run, right? Rate of change is rise over run. So 500 over the run, which is the change in the horizontal values, which is 10. So that equals 50. Note that this looks just like the unit rate too. We're dividing the top by the bottom. It's just like we're just finding the unit rate with the rate of change. Here, in this next case, from 0 to 500, our increase is 500 again, and our increase is 10 here as well. So that's again going to be 50 when it simplifies down. 500 over 10, or 50. In our case here, we go from 500 to 1,250. That's going to be 700, and then over 10, because our increase is still 10 here, that's going to be 75. And then in our final value, we're increasing by 1,000, and again by 10 in the run. So that is going to give us 100. So those are our rates of change at each interval. And notice these are consistent, but these are not. So this is not going to be a linear graph. This is a nonlinear rate of change. So again, rate of change. Remember this, rise over run. It's also known as the slope of the graph, and you'll hear me use that term as well interchangeably. And it's found by looking at the difference in the y values over the change in the x values as you go down the graph as you move. This would be moving horizontally on the x-axis, and this is on the y-axis. You can also do it by looking at the graph and actually counting out the change on the graph.